Hello everyone, this is Moshmi. Let us look at some important problems on motion in a straight line. The first problem, a particle of mass 1 kg is subjected to a force which depends on the position as F equals minus k x I cap plus y j cap in kg meter per second square with k equals 1 kg per second square. So this is per second square. At time t equals 0, the particle's position r equals 1 by root 2 I cap plus root 2 j cap in meters and its velocity is v equals minus root 2 I cap plus root 2 j cap plus 2 by pi k cap in meter per second. Let Vx and Vy denote the x and y components of the particle's velocity respectively. Ignoring gravity, when z equals 0.5, the value of x Vy minus y Vx is. So, a wonderful problem. A particle of mass m has been subjected to a force and the force is dependent on the position of the particle. Let us look at the expression for force. We have F equals minus k x I cap plus y j cap, where k is a constant whose value has been given as 1 kg per second square. Now at time t equals 0, the particle's position is given by r in terms of I cap and j cap, and the velocity is also given in terms of the three components I cap, j cap and k cap. Vx and Vy accordingly denote the x and y components of the particle's velocity. Now when this is the case, we come to know from the question itself that the torque about the origin will be 0, and if torque is 0, then from the principle of conservation of angular momentum, we know that the angular momentum will be conserved. So let's begin with that keynote. The torque about the origin is 0. So torque indicated by the letter tau, this is equal to r cross f, all being vectors. So r and f, we have the values of rf and this is equal to 0. So this tells us that the angular momentum L, which is equal to, we can write this as m r cross v, v is the velocity vector, this is equal to constant. Now, how can we represent this? We already have the values of f, r and v. So let's put in the values and try to express this in terms of numbers or in terms of the components. So we may write, since m r cross v is constant, we may write that r cross v is also a constant. So what is r cross v? The cross product of two vectors may be expressed in terms of determinants. So let's look at that. We may write r cross v as in terms of I cap, j cap and k cap. Let's look at r. We have the component as 1 by root 2 and the j component is root 2. We do not have a k component, so that tells us that it's 0. And v, the components of v in terms of I cap, j cap, k cap are all given in the question. Just look at it and write down the components. We have the first one as minus root 2, the second as root 2 and the third as 2 by pi. So this may be written as equal to, in terms of I cap, j cap and k cap again, the components of the position vector. Components are x, y and z. And z has been given as 0.5. So let's replace z by 0.5. Now looking at the components of v in terms of Vx, Vy and Vz, we have the first as Vx, the second as Vy, and since we do not have Vz, let's use the same constant that is given in the question. So in place of Vz, we are taking it as 2 by pi. This will not spoil the problem in any ways. So let's now solve this. We should keep an eye on what we need to find out. So for the first part, it's I cap. I hope you remember this. So it's root 2 times 2 by pi. So 2 root 2 by pi. We need to give a minus sign in between. It's root 2 times 0. So that gives us 0. Now for the second term. Let's begin with a plus sign. You may be using the minus sign as well. But then you need to take a note on how you are choosing the components. So if we are taking plus j cap, that means that we shall start from the point where we ended. We ended up at 0, ignoring the row and the column in which j cap lies. We have to ignore this column and this particular row, and then we are left with 0 times minus root 2, which is 0 minus of 2 by pi times 1 by root 2. So that's 2 by root 2 pi. Now the third component, k cap, which is, we ended up here. So it's 1 by root 2 times root 2. That's 1 minus of minus root 2 times root 2. So that's plus 1. Let me write an additional step. We write it plus root 2 times root 2. Now, looking at the right hand side, we have I cap times y times 2 by pi minus Vy times 0.5. So it's 2y by pi minus 0.5 times Vy. Then for j cap, we ended up here. So 0.5 times Vx minus 2 by pi times x. 2 by pi times x. And for k cap, we ended up at x. So it is simply this, x Vy minus y Vx. So wait a minute, we are already at the term which we are asked to find out actually. We are asked to find out the value of x Vy minus y Vx. So this is what we need. So we need not solve it any further. We just need to compare the two sides of the equation. So comparing both sides, we can see that x Vy minus y Vx is nothing but the same as 1 plus root 2 times root 2. So root 2 times root 2 is simply 2. So we have 1 plus 2, that is plus 3. So the correct answer for this is 3. Now let's move on to the next problem. So starting at time t equals 0, from the origin with speed 1 meter per second, a particle follows a two-dimensional trajectory in the xy plane so that its coordinates are related by the equation y equals x square by 2. The x and y components of its acceleration are denoted by ax and ay respectively. Then which of the following equations or which of the following options will hold good? So let's begin with whatever we have in hand. The particle has started moving with a speed of 1 meter per second from the origin, when it was at the origin, it did not travel any distance, and at that time, the time was in fact 0. After that, the particle followed a two-dimensional trajectory. That is, it was moving in the xy plane, and its motion is represented by y equals x square by 2. So this is the keynote which will help us in solving the problem. What we have in hand is that y is equal to x square by 2. Now look at the options. We have options of the acceleration in fact. Now this is the position, x and y, they denote the position. So if we are to come to acceleration, we first need to find the velocity, because acceleration is nothing but rate of change of velocity. So let us look at the velocity of the particle, and also we should bear in mind that the velocity has both x and y components, as the particle was moving in the xy plane. So let us first find out the velocity from this. Velocity is nothing but rate of change of displacement. So we have this as dy dt, which will be broken up and written as dy dx times dx dt. So we have ddx of y is nothing but x square by 2, and dx dt, this is nothing but the component of velocity in the x direction. So this is vx, and this velocity dy dt is nothing but the component of velocity in the y direction. So we need to mention here that vx and vy are the x and y components, of velocity. So we have a relation between vy and vx in fact. So ddx of x square by 2 half comes out of the differentiation sign, and ddx of x square is nothing but 2x. So ultimately we are left with x here, and we have vx. So we see that vy is equal to x vx. So this is the velocity, the components of the velocity along the x and y directions. Now trying to find the acceleration from here, what we need to do is we need to differentiate this relation. So what do we have after differentiation? We have ddt of vy, which is nothing but ddt of x vx. So both are differentiable with respect to time. So we have to differentiate both. So what we get here is ddt of vy, which is nothing but the y component of the acceleration, and for the right hand side we have it in this way. We may take x as constant first, and then we have ddt of vx, and the second term will give us vx as constant and ddt of x. So this is what we have. We can write this as ay equals x ax plus dx dt is nothing but vx. So we have vx times vx, that is vx square. Now let us analyze the options to see their validity using these two relations that we have in hand. Now first option, we have ax equal 1 meter per second square, implies that when the particle is at origin, ay will also be equal to 1 meter per second square. Now have a look at this second relation. Ax is 1 meter per second square, this term. This is 1 meter per second square. So we shall get ay as equal to x plus vx square. Now if the particle is at origin, what does it mean? It means that x will be equal to 0, since there is no displacement when the particle starts from origin. So after that we are left with ay equals vx square, and the speed of the particle was 1. So this will give us ay equals 1. So we come to know that this particular option is correct. So this is the correct option. Now let's analyze the second option as well. Ax equals 0. So Ax is 0, that means this first term vanishes. Implies Ay equal 1 meter per second square at all times. So this is also true. Now look at the third option. At t equals 0, the particle's velocity points in the x direction. So when t is equal to 0, that means this is the initial condition, then what we have is that if you are thinking of t as equal to 0, then this x will vanish. So this will give us Vy equals 0, or there is no component of velocity in the y direction as well. So the only component of velocity that exists is in the x direction, or we can say that the particle's velocity will point in the x direction. So we see that the third option is also correct. Now looking at the last option, Ax equals 0 means that at t equal 1 second, the angle between the particle's velocity and the x-axis is 45 degrees. So yes, that is also true. If x equals 0 and the time is equal to 1 second, then this will mean that the particle is moving at certain angle with the horizontal. And since it's just 1 second, so you can say that the particle is moving at an angle of 45 degrees with the x-axis, or we may also say that it is moving at an angle of 45 degrees with the y-axis. So this tells us that the option D is also true. So we have discussed some important problems. We shall be bringing up more in due course. So stay tuned with Academy. Thank you.